Episode 4. Sometimes dreams come true. After the first two anomalies, a near-perfect entry into the planetary plane and an unusually deep negative polarization, we decided to ask one simple, focused question. If 3I Atlas is an artificial object powered by electromagnetic propulsion, how should it behave before its close approach to Mars, 0.19 astronomical units, and before perihelion? Instead of waiting for retrospective analyses, we made clear operational predictions based on a conceptual model of an active electromagnetic system. The ability to organize particles into structured configurations via fields, producing an anti-tail or a tail without classical sublimation. Controlled activation of internal components leading to a brightness increase not driven by solar heating. Thrusts or maneuvers that would generate non-gravitational accelerations even far from the Sun. Our expectation was simple. If our model is correct, we should see synchronized optical and dynamical changes within a short time window. Not necessarily on the same day, but within a single connected observational window. And most importantly, we made these predictions before any of this happened. And they came true. 1. The anti-tail that changed. Appearance, then a transition to a regular tail. Observations from late August to early September showed a disturbing behavior. A clear anti-tail, a tail pointing toward the Sun. But according to analyses based on wide-field imagery and reported in Loeb's work, during the window September 12th to 21st, the anti-tail underwent a distinct shift into a regular tail, pointing away from the Sun. Key points. The anti-tail appeared when the object was still far from the Sun, a situation that doesn't match classical sublimation models. In a natural model, explaining both the early anti-tail and the later tail requires combining rare conditions: partial breakup, sudden compositional change, and a precisely timed burst of material. Under an electromagnetic propulsion hypothesis, the behavior becomes intuitive. Active fields sorting particles can create an anti-tail, and a shift in field configuration can reorganize emissions into a standard tail. A controlled or programmed transition. Brightening begins early. Graphs and analyses show a clear, organized increase in brightness beginning around September 16th, exactly within the same time window in which the anti-tail transitioned. Why is this problematic for a natural comet? Typical comets brighten when solar heating becomes strong enough to drive critical sublimation. Here, the brightening starts far too early relative to expected heating, meaning a different mechanism must be operating. Under the technological model, this resembles system activation, internal components powering on, controlled particle or plasma emissions, exposure of engineered surfaces designed to reflect efficiently. In other words, a brightness increase that can be triggered deliberately. 3. The onset of non-gravitational acceleration, changes in R. Beginning around September 16th, we tracked changes in the radial velocity directly from JPL Horizon's ephemerides, day by day, because at that time, JPL had not yet published explicit non-gravitational solutions. The analysis shows a significant deviation from purely gravitational motion beginning around September 16th, again within exactly the same window. Highlights. The non-gravitational acceleration begins well before perihelion and before any official trajectory updates acknowledged it. Classical sublimation mechanisms struggle to explain such measured thrust at distances where solar heating is still weak. An electromagnetic propulsion system can generate thrust at large heliocentric distances, independent of solar heat, naturally explaining the deviations. The combined picture, a systemic correlation in a narrow time window. These events did not happen on a single day, but they did happen in a tight observational window, September 12th to 21st. 1. Anti-tail appears, then transitions into a regular tail. 2. Brightening begins, approximately September 16th. 3. Radial velocity deviation begins, approximately September 16th. These three components, optical, structural, and dynamical, occurred together and in sequence. This is not a collection of random, unrelated anomalies. This is a coherent pattern with temporal linkage, a signature of system behavior. Why the technological explanation is simpler and more reasonable. Natural scenario. To explain these three phenomena naturally, one must assume a partial breakup at a specific moment, a sudden, massive release of material in unusually high quantities, abrupt change in particle sorting and dust dynamics, perfect timing, all within a narrow window. This requires many independent assumptions. The required coincidence is extremely low. Technological scenario. An active electromagnetic system provides fields that organize particles, anti-tail, controlled shift to tail, internal system activation, early brightening without solar heating, EM or plasma thrusters, non-gravitational acceleration far from the Sun. One unified framework explains all three. Fewer assumptions, less coincidence, higher coherence. Chapter 4. Summary. During the September 12th to 21st observation window, we saw a correlation of three key signatures. 1. An anti-tail transitioning into a regular tail, as described in R.V. Loeb's analysis. 2. A premature brightness increase around September 16th. 3. Non-gravitational acceleration beginning long before perihelion and before official trajectory updates. The chronological coherence and the difficulty of explaining all three naturally strengthens the case that a technological model, electromagnetic propulsion, controlled system behavior, is the simplest and most consistent explanation so far. Sources: JPL Horizons Ephemeris, R.V. Loeb's articles on the anti-tail transition, rapid brightening of 3I Atlas ahead of perihelion. Want more? Subscribe, drop a like, and join us. We're only getting started.